Let's look at solving radical equations. I know what you're probably thinking, wow, this must be so awesome, like radical, right? Yeah, man, like so awesome. Let's talk about the power property. Do you remember the power property? Power property says the following. It says, all solutions to the equation, A equals B can be found among solutions to A to the n, bless you, equals B to the n. So basically what this says is that we can raise both sides of the equation to the same power. And we're going to be okay. Isn't that nice? Now you really kind of want to be careful here. You want n to be n is a positive integer. Okay, just go with me on this. Trust me. N is a positive integer. Now, some of these guys are actually pretty easy, but you just have to allow them to be easy.
Does that mean it's got to be a whole number? It can't be a fraction?
Right, positive integer. So, for example, if I have the fourth root of 5x plus 21 minus 4 is equal to 2. This power property says I can raise both sides to the appropriate power if that's going to help me out. But there's one thing we have to be very, very careful about. We should use a we must always remember this. Isolate a radical first. If you don't isolate, then you won't be able to use the power property correctly. So what should I do here? Move the 4 to the other side. So I have the fourth root of 5x plus 21 equals what? It equals 6, right? No?
Yes.
2 plus 4 is not 6? Do you all agree with that?
Yes.
Now, the reason I wanted to isolate this radical was so that I could use that power property. What's the power that I'm going to use to help me out? Because see, the x is inside the radical. That's not a good place for him to be. Just like in the last problems, x was in the denominator. That's not a good place for him to be. How do I correct this guy?
Raise it to the fourth.
Raise this to the fourth power, both sides, right?
Mm-hmm.
So what happens here?
It goes away.
The fourth root and the power of 4 will reduce. 5x plus 21, you know 6 to the fourth because it's on your power sheet, and you get what? The plus or minus is what comes in when you take the square root of both sides. You only see that with the square root property. Even though this has a radical, I'm not taking the square root of both sides, so the plus or minus does not come into play. Look at my equation now. Is this quadratic or linear? It's linear, so you solve it using linear methods, which means you do what? Subtract 21. And then divide by 5. Excuse me, x equals what? X equals 255, which, by the way, is the maximum number of rupees that Link can carry in the original Legend of Zelda game.
Really? That was the limit? No, seriously, that was the limit?
That was the limit because it's based on powers of 2. Because 256 is 2 to the 8th power. You may say, why doesn't it go up to 256? It has 256 places because there's 0. 0 to 255 is 256 places. You just learned something else new today. Now you always want to check these guys. If you plug this back in, is it going to work? Well, if you do 255 times 5, you get 1,275 plus 21 is 1296. What's the fourth root of 1296? How can I do that on the calculator?
6. Right.
Oh, it's 6?
Yeah, seriously.
Seriously, what?
It's 6.
Okay, well, I didn't. Not to say I don't believe you guys. But you know, let's do something different. I'm going to do this. 255 store into x. And I want to do the fourth root of this guy. So I'm going to kind of go old school here. I'm going to do 5x plus 21 raised to the what? 1/4 power minus 4. That should equal what?
2.
It equals 2. So I was able to verify my work. This is not going to be a fun guide to verify graphing because the solution is x equals 255, right? In your standard graphing window, how far out does it go?
10.
It goes out to 10, so you'd have to seriously adjust your window just to see the intersection. To me, that sounds like a waste of time. So I'm going to go with what I know.